Teacher Ai. Welcome to my class. Our lesson for today is all about identifying the appropriate rejection region for a given level of significance.
Our objectives are: define the critical values, level of significance, hypothesis test, and rejection region. Identify the critical value when population variance is known or unknown. And lastly, determine the appropriate rejection region for a given level of significance when population is known or unknown and central limit test is to be used. To start with, let us have a little review regarding a standard normal curve. Given this figure, we can have the given z value at the bottom, wherein the given value are 0, 1, 2, and 3, and to the left side is -1, -2, and -3. Let's have this activity entitled Bring Color to My Life. The task says, given a standard normal curve, shade the required area with color green, and for the remaining area, use color red. The given value that we're going to do first is between z is equal to -1.56 and z is equal to +1.56. Using the standard normal curve, let us locate these two given values. And given this, let us now shade the required area since we are looking for the area between -1.56 and +1.56 and shade it with color green. And the remaining parts will be red. Now, let us try this. To the left of z is equal to 2.05. Now, let us use the standard normal curve and then locate the given value of 2.05. After that, let us analyze the given. The given problem refers to the left of z, which is 2.05. So, the given area is this. Now, let us shade it. And the remaining area is colored red. Now, let us try this one. To the right of z is equal to -1.3. Again, let us use the standard normal curve and locate -1.3. After locating -1.3, let us again analyze the given problem. It says right of -1.3. Therefore, we are referring to this region. This region will now be colored green. And the remaining part will be red. Now, let's take this situation and analyze the problem so that later on we're going to answer what is being asked. Banana company claims that the mean weight of their banana is 150 grams with a standard deviation of 18 grams. Data generated from a sample of 49 bananas randomly selected indicated a mean weight of 153.5 grams per banana. Is there sufficient evidence to reject the company's claim? Use the level of significance alpha, which is 0.05. What is now the question, or what are the questions that we're going to answer later on? The first one is, what are the hypotheses? Next, is it two-tailed or one-tailed test? Next, what is the level of significance? Is the population standard deviation known? What appropriate test statistic can be used? Based on the level of significance, hypothesis test, and test statistic, what is the critical value? And lastly, draw the rejection region. To be able for us to answer that, let us start with the definition of critical value. In hypothesis testing, a critical value is a point of the test distribution that is compared to the test statistic to determine whether to reject the null hypothesis. Critical values for a test hypothesis depend upon the test statistic, which is specific to the type of test, and significance level, which defines the sensitivity of the test. Always remember, the given critical values depends on the specific type of test and the significance level. Now, let us determine the critical value of z distribution. A critical value of z, or known to be z-score, is used when the sampling distribution is normal or close to normal. Z-scores are used when the population standard deviation is known or when you have larger sample sizes, while the z-score can also be used to calculate probability for unknown standard deviations and small samples. Here is an illustration of the table of critical values, or what we all know, z-score. Now, let us use the table of critical values to be able to answer this task. Find the critical z-values. In each case, assume that the normal distribution applies. With the given left-tailed test with alpha, which is 0.01. Using the table of critical value, we can see here is the left-tailed test, and here is the given significance level, which is 0.01. Therefore, our critical value is negative 2.33. Now, let's have another one. Two-tailed test with a given alpha of 0.05. Using the given table, let us locate the two-tailed test, which is here, and the alpha, which is 0.05. Therefore, the given critical value is positive negative 1.96. Now let's take this last one. Right-tailed test with alpha or significance level of 0.025. Using again the critical table of values, let us determine the right-tailed test on the given table and its level of significance, which is 0.025. Locating the critical value, we have 1.96. Since it's right-tailed, it is positive 1.96. Now, let us determine the critical value of t-distribution. The t-distribution table values are critical values of the t-distribution. The column header is the t-distribution probabilities, or alpha, and the row names are the degrees of freedom. Now, let us utilize the use of a given t-table in this kind of situation. Find the critical values for t-distribution. The task, find the critical t-value for a left-tailed test with the alpha given of 0.05 and the sample, which is 21. If you're going to observe the given problem, we are referring to one-tailed test. Using this table, let us now determine by following this step-by-step procedure. First, identify the level of significance. Here, our level of significance is 0.05. Second, let us apply the formula for finding the degree of freedom, which is degree of freedom is equal to n minus 1. Using this, since our sample is 21, 21 minus 1 is 20. And if we're going to locate that in our table, we have 20. Since we are referring to one-tailed test, and our level of significance is 0.05, let's now find the critical value using our t-distribution table. Locating 20 and the level of significance, we have 1.725. Since we are referring to left-tailed test, therefore our critical value is negative 1.725. Now let's try this one. Find the critical t-value for a right-tailed test with the given alpha 0.01 and the sample of 17. Using our t-table, let us determine the right-tailed test, which falls on a one-tailed test on our given t-table. And our alpha, which is 0.01, is located here. Now, using our given sample, let us determine the degree of freedom. By using the formula, degree of freedom is equal to n minus 1. Arriving to an answer, we have 16. On our t-table, 16 falls here. Now, with the use of level significance and degree of freedom, we're going now to locate the given critical value, which is 2.583. Since we are referring to right-tailed test, our given t-value will be positive 2.583. Now let us try this. Find the critical t-values for two-tailed test with a given alpha of 0.05 and a sample of 26. Using our t-table, let us locate the two-tailed test, which is here. And our given alpha, which is 0.05. And using our given sample, which is 26, let us determine the degree of freedom using the formula n minus 1, and we arrive to 25. 25 is located here on our T table. And determining the given degree of freedom and the level of significance, we arrive to our critical value, which is 2.060. Since we are referring to two-tailed, the value of t will be positive negative 2.060. Now let us discuss critical regions or rejection region. Critical region are also known as the rejection region. Describes the entire area of values that indicates you reject the null hypothesis. In other words, the critical region is the area encompassed by the values not included in the acceptance region. To determine the critical region for a normal distribution, we use a table for the standard normal distribution. If the level of significance is alpha, which is 0.10, then for one-tailed, the critical region is below negative 1.828 or above 1.28. For a two-tailed test, we used alpha over 2, which is 0.05, and the critical region is below or above 1.645. Moving on to our next topic, all about rejection region if population variance is unknown. To determine the critical region for a t-distribution, we use t-table. Assume that we use this t-table with 20 as our degree of freedom. If the level of significance is alpha, which is 0.10, then for a one-tailed test, the t-value could be negative 1.325 or positive 1.325. For two-tailed tests, we use the alpha over 2, which is 0.05, and then our t would be negative positive or positive negative 1.725. Now, let's have hypothesis tests and their tails. There are three types of tests from a tail standpoint. The first one is a left tail test, only has tail on the left side of the graph. To illustrate, we're going to shade the left side of the given standard normal curve. This shows the rejection area. Next, right-tailed test only has a tail on the right side of the graph. To illustrate, this shows the rejection area of the graph. A two-tailed test has tails on both ends of the graph. To illustrate, this is known to be the rejection region. Now, to deepen our understanding, let us determine the critical values and the appropriate rejection region. Sketch the sampling distribution. The given right-tailed test with the given population standard deviation, which is known, and the given level of significance, which is 0.05, and the sample, which is 34. Using our given illustration or the normal standard curve, let us apply the given data. Our right-tailed test, which is illustrated here, and the alpha, which is 0.05, which is here. Therefore, our critical value falls on 1.645, which is located on the given right side, which is our rejection region. Now, let's have another one. Two-tailed test where the given population standard deviation is unknown, the given level significance is 0.05 with a sample of 10. Here, we're going to use the t-table since the given value is less than 30. Using our standard normal curve figure, let us apply our given t-table. We locate the given value for two-tailed, which is here, and our given level significance, which is 0.05. Therefore, given our degree of freedom, which is 9, coming from the given sample of 10, which is 10 minus 1, and the result is 9, we arrive to the given critical value, which is 2.262. By illustrating that in our graph, we have the given shades on our left and our right side, which results to be the rejection region. Now, let us take this given situation for us to deepen our understanding to identify the critical value when population variance is known or unknown, and determine the appropriate rejection region for a given level of significance when population is known or unknown. Let us read the problem. A survey reports a customer in the drive-thru lane of one fast food chain spends 8 minutes to wait for his or her order. A sample of 24 customers at the drive-thru lane showed mean of 7.5 minutes with a standard deviation of 3.2 minutes. Is the waiting time at the drive-thru lanes less than that of the survey made? Use 0.05 significance level. To clearly understand the given, let us enumerate the given using this given table. The hypothesis here is the null hypothesis is the mean, which is 8, and the alternative is the mean is less than 8, which refers to the minutes of the given customer waited for his or her order. The hypothesis test here that will be used is left-tail test, since the alternative hypothesis showed less than symbol. Population standard here is unknown, and the level significance is 0.05. The sample is 24, and since the given standard deviation is unknown, and the given sample is greater than 30, we're going to use t-value. Utilizing this table for us to be able to illustrate the rejection region, we're going to use the standard normal curve and the t-table. Under our t-table, the given hypothesis test falls on one-tailed test, since it is left-tailed test, and our level of significance, which is 0.05, and with the use of our sample, which is 24, with the use of our degree of freedom, which will turn to be 23, locating that using our level of significance and our degree of freedom, we arrive to our critical value, which is 1.714. Let us locate it in our given standard normal curve. Therefore, since that is in the left tail, the sign will be negative 1.714. Let us now shade and identify the rejection region. Going back to the problem a while ago about the banana company who claims the mean weight of their banana, which is 150 grams, with a standard deviation of 18 grams. The data generated from a sample of 49 bananas were randomly selected indicated a mean weight of 153.5 grams. Is there sufficient evidence to reject the company's claim using our level of significance alpha, which is 0.05? Going back again to the questions are, what are the hypotheses? Is it two-tailed or one-tailed test? What's the level of significance? Is the population standard deviation known? What will be the appropriate test statistic? What is the critical value? And draw the rejection region. Utilizing this table to summarize the given hypothesis, hypothesis test, population standard if it is known or unknown, level of significance, number of sample, and the type of test that we'll be going to use. Since we are indicating the null hypothesis here, which is equal and not equal to 150, we are referring now to two-tailed test. And the question of level of significance is clearly stated as 0.05. Since the question is what appropriate test statistic should be used, referring that the population standard deviation is known and the given samples is greater than 30, the test statistic that would be used would be z-value. Now, let us utilize this table for us to illustrate the rejection region of the given problem a while ago. using our standard normal curve, and since the given t-statistic we're going to use is z-value, we're going to use the critical value for z-score. Given this hypothesis test, which is two-tailed, we're going to use this to determine the level of significance and its critical value, which is positive negative 1.96. Locating that in our given figure, we have the negative 1.96 to the left side and positive 1.96 to the right side, shading the given region, which illustrates that this is our rejection region. Now, let us move on to the summary of today's lesson. First one is the critical value, which is a point on the test distribution that is compared to the test statistic to determine whether to reject the null hypothesis. We also discussed the given critical value of z distribution, which is used when the population standard deviation is known or when you have larger sample sizes. We also have utilized the given C table with the level of significance used for different type of test. We also have the critical value of T distribution and given the T table, which involves the degree of freedom and the level of significance. Now let us move on to your module and do page 12, activity number 1, entitled What is my value? With the given direction, find the critical value of the following. And the activity number 2, which is entitled Reject It, which directs us to find the rejection region for each hypothesis test based on the information given. And also the activity number 3, which is entitled Let us do the sketch. It instructs us to sketch the graph given the critical value and rejection region. That's all for today, class. Thank you for listening and always remember, aim high, senior high.